Module 3, Relational Database Design. Principles of Relational Database Design. Relational database design follows certain principles to ensure that databases are well-structured, efficient, and capable of storing and retrieving data accurately. Here are some key principles of relational database design. 1. Entity relationship, modeling. Modeling is a technique used to represent the entities, objects or things, in a system, their attributes, properties or characteristics, and the relationships between entities. Diagrams are used to visually represent the entities, attributes, and relationships in a database, which helps in understanding the structure of the database and its relationships. 2. Normalization. Normalization is the process of organizing data in a database in a way that eliminates redundancy and ensures data integrity. There are several normal forms, including first normal form, 1NF, second normal form, 2NF, third normal form, 3NF, and Boyce-Codd normal form, BCNF, among others. Normalization helps in reducing data duplication, improving data consistency, and simplifying database maintenance. 3. Data integrity. Data integrity refers to the accuracy, consistency, and reliability of data stored in a database. Ensuring data integrity is crucial for maintaining the quality and reliability of the data in a database. Techniques such as primary keys, foreign keys, constraints, and validation rules are used to enforce data integrity in a relational database. 4. Relationship cardinality. Relationship cardinality defines the number of occurrences of one entity that are related to the number of occurrences of another entity in a relationship. Common relationship cardinalities include 1-to-1, 1:1, 1-to-many, 1, m, and many-to-many, m, n. Properly defining relationship cardinality is essential for accurately representing the relationships between entities in a database. 5. Data types. Data types define the type of data that can be stored in a particular column of a database table. Common data types include integer, float, string, date, time, and Boolean, among others. Appropriate use of data types ensures that data is stored efficiently and accurately, and it also helps in performing operations such as sorting, filtering, and searching on the data. 6. Indexing. Indexing is the process of creating data structures that allow for fast and efficient retrieval of data from a database. Indexes are used to speed up query performance and improve the overall performance of a database. Proper use of indexing can significantly enhance the performance of a relational database. 7. Scalability and performance. Relational database design should take into consideration the scalability and performance requirements of the system. This includes designing the database to handle large amounts of data efficiently, optimizing query performance, and ensuring that the database can scale as the data and user load grows. These are some of the key principles of relational database design. Following these principles helps in creating well-structured, efficient, and reliable databases that can accurately store and retrieve data for various applications and use cases. Data normalization and normalization forms. Data normalization is the process of organizing data in a relational database in a way that eliminates redundancy and ensures data integrity. It involves breaking down a database into smaller, more manageable tables and establishing relationships between them. Normalization is an essential step in database design to improve data consistency, reduce data duplication, and simplify database maintenance. There are several normal forms in database normalization, each with its own set of rules. The most commonly used normalization forms are 1. First normal form, 1NF. In 1NF, each column in a table must contain atomic values, which means that each value in a column must be indivisible. The table should have a primary key that uniquely identifies each row, and there should be no repeating groups or arrays. 2. Second normal form, 2NF. In 2NF, the table must meet the requirements of 1NF, and all non-primary key columns must be fully dependent on the primary key. This means that no partial dependencies are allowed, where a non-primary key column depends on only part of the primary key. 3. Third normal form, 3NF. In 3NF, the table must meet the requirements of 2NF, and there should be no transitive dependencies. Transitive dependencies occur when a non-primary key column depends on another non-primary key column, which in turn depends on the primary key. 4. Boyce-Codd normal form, BCNF. BCNF is a stronger form of normalization that eliminates all possible anomalies related to functional dependencies. In BCNF, a table must meet the requirements of 3NF, and every determinant, a column or set of columns that determines the values of other columns, must be a candidate key. 5. Fourth normal form, for NF. 4NF is a further normalization form that deals with multi-valued dependencies. In 4NF, a table must meet the requirements of BCNF, and it must also not have any non-trivial multi-valued dependencies. 6. Fifth normal form, 5NF. 5NF is the highest level of normalization that deals with join dependencies. In 5NF, a table must meet the requirements of 4NF, and it must also not have any non-trivial join dependencies. These are some of the commonly used normalization forms in database design. Each normalization form has its own benefits and trade-offs, and the choice of normalization form depends on the specific requirements and characteristics of the database being designed. Proper normalization helps in creating a well-structured and efficient database that is free from redundancy and ensures data integrity.
Thanks for watching. For more information, like, comment, and subscribe our channel.